Hey, welcome to The Explainer. Today, we're going to be unlocking some of those really tricky trigonometric identities. And listen, these aren't just some abstract puzzles you do for homework. They are literally the building blocks for some of the most powerful technologies we use every single day. We're going to show you 3 key techniques that'll help you solve even the toughest ones out there.
Come on, you know the feeling. We've all been there. You're staring at an equation, you've tried everything you can think of, and you've just hit a wall. It's so frustrating, right? Well, today we're going to give you the tools to smash right through that wall. Okay, so let's dive in. You've probably already learned the #1 rule of trig identities. When you're in doubt, just convert everything to sine and cosine. And you know what? It's a great strategy. But what happens when that's not enough? That's where we're headed today. Yeah, these tougher identities, they need a little more than just basic substitutions. They need some real algebraic muscle. Seriously, think of it like you're upgrading from a simple wrench to a full-on power toolkit.
So, what's in this new toolkit, you ask? Well, we're going to break down 3 really powerful techniques: finding a common denominator, multiplying by something called the conjugate, and good old factoring. Let's see what they are, and more importantly, when to use them.
And this slide right here, this is your roadmap. It's not just some list of techniques, it's a guide. It tells you exactly which tool to grab based on the patterns you see in the problem. This is all about pattern recognition, and it's gonna make things so much easier. And we have to focus on this conjugate trick for just a second because, honestly, it's genius. It takes a messy 2-term denominator like 1 minus sine theta, and bam, with one simple move, it magically transforms it into a clean, single term using a Pythagorean identity. It is an absolute game changer. Okay, theory is great and all, but let's actually see these tools in action. Time for our first example. All right, here's our first problem. What you see right away. On the left side, we've got 2 separate terms that just look like they need to be pushed together. That, my friends, is a flashing neon sign telling us to find a common denominator. And look at how this plays out. We create that single fraction, we apply a quick Pythagorean identity to the top, and then we just strategically break it apart again. And just like that, in 4 clean steps, the identity is proven. Okay, next up. Take a look at that denominator on the left, 1 minus sine of theta. Ding, ding, ding. That should be a trigger going off in your mind. This is the absolute perfect scenario to pull out that super powerful conjugate trick we were just talking about. So we multiply the top and the bottom by the conjugate, right? That instantly turns the denominator into cos squared theta. Then a simple cancellation of a cos theta from the top and bottom, and what are we left with? Exactly what's on the right side. Boom, identity verified. And for our final example, look at that numerator. You've got something squared minus 1. That is a classic algebraic pattern. It's a difference of squares, and it is just begging to be factored. So here's the key. Once you factor that numerator, you immediately see a common term on the top and on the bottom. They just cancel out. And you're left with exactly what you need. The identity is proven in, 2 elegant moves? So nice. Now, before we finish up, I have to share a pro tip with you. This is going to save you from a really common and really easy mistake to make. This is especially true when you're using that conjugate method. Listen up, because this is important. You absolutely have to multiply both the numerator and the denominator by the conjugate. You have to. Remember, you're not trying to change the value of the expression, you're just changing how it looks. And multiplying the top and bottom by the same thing? Well, that's just a clever way of multiplying by 1. So at this point, you might be thinking, okay, this is some cool algebraic practice, but why does any of this actually matter in the real world? Well, it turns out that verifying these identities has a kind of secret mission that is absolutely crucial to our modern world. You heard that right. Modern cryptography, the rigorous, logical, step-by-step process of proving that 2 things that look totally different are actually identical, that is the exact same kind of reasoning used to build the security proofs that keep all of our digital communications safe. So the next time you're stuck on a trig identity, just remember, you're not just solving for theta, you're actually training your brain in the kind of bulletproof logic that powers the modern world. It really makes you wonder, doesn't it? What other secrets are hiding inside your math homework? Keep exploring.